All right.
Welcome to another episode of the Rollup.
Gil, the CTO of Lava Network. Rob, looking pretty sage over there, man.
Honestly, from one sage to a maverick, it's a pleasure to be here, and it's a pleasure to have you on, Jill.
Thanks, guys.
Yeah, man. Took a brief look at the presentation. I'm very excited to dive into the RPC landscape.
Awesome. Thank you for hosting me. Great chatting with you guys again. So let's talk about Lava. Let's talk about RPC. Let's talk about modular thesis. Now everything connects. So my name is Gil. I'm the co-founder and CTO of Lava. Also one of the core contributors to the network. My background is originally from cybersecurity. Over 15 years of experience in taking really complex systems like kernels, browsers, operating systems, breaking them apart, understanding how they work, and finding flaws in their systems. I got into the space by doing MEV. So that's what brought me in, building bots on mainnet. Been doing Lava for 2 years now, almost 2 years actually. And we've built a really strong team of amazing engineers. So we'll talk today about what the modular stack is, what is RPC, how it fits in, the story of Lava, how it works. And if you guys have any questions, Rob, please let me know. Feel free to stop me. So you guys already know this, but we're living in a multi-chain era. Everybody was talking about this a couple of years back, and we're now seeing that reality come into life. And we're seeing, from monolithic chains, today we saw the announcement from Monad, to many Rollups, and obviously app chains of Cosmos and the likes. And it is really amazing to see all these new chains come and solve new problems for users. The advent of DA allowing for cheaper gas and more transactions for users. Unfortunately, one of the downsides of having at this current stage of the game, of having so many chains, is the fragmentation that we're seeing. If it's from liquidity perspective, or just like managing many different wallets from a chain abstraction perspective. And from a developer experience, obviously, building for all these chains is like super tough for many reasons that we'll dive into. But definitely we're seeing now that, many more chains are coming up. And why is that? That is because it's so much easier to build, right? So we are now basically developing on the shoulders of giants. We have, amazing execution layers, settlement, consensus, amazing projects, from Celestia, from Eigenlayer, EigenDA, which we saw launch on mainnet today as well. Crazy day. Fluent, Avail, Dimension, we've been seeing Eclipse. So really incredible projects that are building these layers. And what that allows, it enables, everybody to build faster and everybody to focus on what's really important for users and bringing their crowd, bringing the users to actually to focus on business logic for developers, which is, I think, super crucial. But there is one part that is like super painful. Everybody uses it. You guys use it every day. But no one talks about it. And we call this data access, right? So how do you access blockchains? So quickly overview, blockchains are these amazing distributed databases. So you have basically, let's call it like an Excel file. So if it's not distributed or centralized, it's just like a file on your computer. But if you have the Excel file on a different server, on what we call Web3 and Node, and then Node syncs over peer-to-peer network with many other nodes, and those Excel files are basically replicated, and everybody agrees to the content of these Excel files. Excuse me for using Excel as an example, but I think it's really simple. So now we have a distributed state, and it's an amazing, beautiful thing. It's like a new primitive for computation, right? It's a new way to build things in a way that's decentralized, permissionless, trustless. So how do we read from these databases? So we can't just access them on our computer because we don't have the file. We don't have the Excel file. So we have to talk to a server, a node that has those files. So every time that you are doing any basic operation with a blockchain, it requires you to basically talk to these RPC nodes. It's crucial. It's imperative that you have these nodes, these RPC providers, because without them, you wouldn't be able to access any data. So how do you write to these Excel files? Basically, every time you send a transaction, you're sending it to an RPC provider. This RPC provider has nodes, and these nodes gossip in most blockchains these transactions to each other, and eventually there's a validator that puts them in a block, and then gossips back to block to all these nodes. So now we wrote to this Excel, and then our Excel is updated with what we put in there. In the initial vision of blockchains, people thought that everyone will be running these nodes, right? Everybody will be running nodes, and there's also something called a light client, which we might touch on later, which is a way to prove the data is correct in a simpler, lighter way than running a node.
And Gil, quick question on even in the context of a light client, if a light client is a way to prove that data is correct, I still have to get that data somehow. And so is that the data access question? Is how do I get that data? And then proving that the data is correct is kind of another job. It's another job for what a light client would do. But a light client still has to get that data for it to verify it.
So light client is a big topic, and there's many different types of light clients. But in generally you're right. Like think about the light client as a way to maybe get some of the data and know that it's trustworthy by talking to many peers in a lighter way and not having to sync the entire chain. But most light clients still require a full node, which is like this Excel file to talk to get the data. So what we're talking about is this core part of blockchains that no one talks about, which is like, how do we access the data? And blockchains, sorry for saying this, but they're basically useless without RPC. They're useless. They're just these files no one can access. So what is RPC? RPC is like this core protocol that almost all blockchains use to get data from their blockchain. So it's called remote procedure call. It's basically a communication protocol. It allows you like to send a query to a server, let's say an RPC provider. It moves it to a node, and it executes the query or the Excel file. Let's say it's set in row 5 to 6, and it returns it to the user. Some really basic communication that you could do is like, getting a user's balance. Let's say you want your balance of your wallet. So you would use an RPC from the browser, for example, to go and ask an RPC provider, what is my balance? When you want to send a transaction, same thing. And you can see that in the center, we have this RPC provider. This RPC provider is someone that we are super, super reliant on, dependent on, to execute anything on a blockchain. All interactions with the blockchains are made through these RPC providers. This is why it's a crucial piece of blockchains in general. So some more examples of what you could do, from deploying a contract, checking your wallet balance, even like maintaining a Uniswap trade, anything that you do that interacts with the blockchain is dependent on these RPC provider, dependent on making these communications. If no one ran RPC nodes, you wouldn't be able to do that again. You would be stuck with a useless file that no one can access.
Yeah, and real quick on that, Jill, why is there not like a standard for RPCs where sometimes I go on, a Anchor RPC or a Pocket RPC, which works better than a Infura RPC because that one has a lot of traffic, but isn't it still kind of connecting to the same network? And it's like why is it not just like, okay, we have this one standardized RPC that always is going to work? What's the blocker there?
Well, you jumped the gun. This is exactly what we're building, right? So RPCs are really, really tough. Why? Because they're very difficult to scale and they're fragmented, and each blockchain defines their own APIs, their own interfaces. So it's very hard to standardize because everybody basically, out of necessity, like built their own solution. So there's like a mishmash, fragmented solutions for every chain. We're really coming to change that and to basically make it access there for everybody. We'll talk about that in a second.
Yeah. So when they're getting clogged, Joe, real quick, when they're getting clogged, like when there's a lot of requests, these like all these calls and actions are what's happening when I click a button on, like MetaMask or Rabby, these types of calls and codes are being ran. And if there's too many being run at once, then it gets kind of messed up.
Exactly. And so just like you go to, let's say, a Web2, page, and everybody's going to that page, if it's not properly built to scale, it's going to crash, right? So, for example, ETH_get_balance, every time you go to your wallet, you see that, you would see that on the network, go from your computer to an RPC provider, and then to a node, and then get back to you. So every single time you do it, there's like hundreds of these calls being made to RPC providers.
Gotcha.
So, how do people actually get access to these RPCs? I think that's a really interesting question. So today, the majority of users and developers are using a free service, using a public RPC that's either it's usually subsidized by either the wallet or the actual blockchain. So most of the blockchains today subsidize access, either rollups, monolithic L1s, and app chains. They will subsidize access to give users the ability to actually use their blockchain, because it's like the door. Like without a door, you can't get anywhere. So I think it's really interesting to see that the vast majority of developers are using these free services to actually use the blockchain. So what do blockchains do? And mind you, every single blockchain in this, and going back to this multi-chain era that we are in now, and it's only the beginning, right? This is only the beginning of the number of chains, number of rollups we're going to see. Every single one of them has to think about these things. So what are they doing right now? Some chains, they run their own nodes. Some chains, they spend millions of dollars, outsourcing it to vendors. Some chains rely on community node providers, and they're all doing it because it's necessary, and it's without it, they would be able to give access to their users. So when they're launching these chains, you're a chain, you're launching your chain. You have to think about bootstrapping these RPC nodes. So, everybody knows about validators, right? Everybody knows that when you're launching your own chain that has validators, you have to bootstrap your validators. But bootstrapping validators is much easier. Why? Because there's inherent incentives, right? So a validator, they stake tokens, and people delegate to that, and they get a commission, and they make rewards from producing blocks. But where is this incentive for RPC providers? It just doesn't exist. So it's a really, really big problem in this industry. So all of these chains, as they're bootstrapping the validator sets, they also have to bootstrap RPC. So we're talking about, making it capital efficient for them. It also needs to be cost effective to run these nodes. It has to be scalable for these chains. They have to make it scalable for their users. And they also have to make sure that if you're a chain, we recently saw a few testnets, for example, and for blockchains where users were not able to use the software. They were not able to use the blockchain because the RPCs were clogged. So from their perspective, all that momentum, is really, really getting people stuck and frustrated, and they're not coming back. So for developers, and we see this, I'm sure you guys saw this, and every time you go to claim an airdrop, you get like, oh, shit, RPC error, we can't do it. Oh, we can't send transaction. A new chain just launched. A new testnet just launched. You can't send transactions. Or your balance is not showing up. This is all because of that clogged RPCs, because you're relying on a single RPC provider. And if that RPC provider is down, it's clogged, it's, it didn't scale properly, then you're stuck, and everyone gets frustrated. So more things that are problems currently with this types of setup is that when you have this RPC provider, remember it was in the center. How much power does it have? It sees everything that you are doing. It's like this eye seeing, okay, you're doing DeFi, you're trying to trade, you want to buy this NFT. It sees everything that you do. And then it says that you're actually doing it. You're sending transactions. So it knows. Maybe it knows how to connect your wallet address with your RPC queries. And then it can take the data and sell it. That's crazy. I think we definitely want to build things around that in Web3. Also, yeah.
Yeah, I think that's a really important point, because in traditional finance, you see these things like payment for order flow. And I think there's this common thing in even like social media and technology applications where if it's free, you're the product, right? You've probably heard that before. And so when most of the RPCs that are available are public RPCs and offered for free, I think there's like, well, why is this free? Am I the product? Are they profiting off of my order flow? Are we recreating the traditional financial system, some of the things that we're trying to get away from, in a more open, free, decentralized economy? And so yeah, how do we solve that incentive problem? This maybe is what you're getting to.
I'm getting into it, but I think it's a really good point, right? So I think that there are some really bad incentives today, and there's some really good incentives popping up, actually. So I'm super positive about the space when it comes to that narrative. And I'll show you what we built, where we're building in Lava, that actually solves this incentive problem. But just to address this one more time, you were talking about order flow payments, pay for order flow, that actually already exists in Web3. Like you have it with Ethereum, you have it with many other blockchains, where basically all the transactions are routed to bots. It's already happening. And these users sometimes get their value is extracted by these bots, by different attacks. So it's really crazy. One more thing that's super important is if you go back to that Excel file that I was talking about, which is like the database of this blockchain. How do you know that you're not getting a stale file from 2 hours ago, where everybody already agreed to these, 10,000 more lines in the Excel or changes, but you're still seeing that old file? So the staleness problem is also a really, really big problem. And I think the key thing I want people to take, just talking about it, is that this is not just a problem for one chain. So as we grow as an ecosystem, and the number of chains multiplies, you have more and more app chains, more and more rollups, you have more and more of these issues. And I think we have to solve it in the right way. So
Joe, real quick, before we jump into Lava, I know you're stoked on it. How much data are these companies actually taking from us on RPC? Like what does Infura know about me?
I don't want to specifically maybe talk about individual providers, but
okay, then what do they know about me?
They know a lot. I don't know what they collect or not. Okay, so let's say you go out, you want to take a loan, or you want to deposit some collateral, and you're looking at different pools to do that. They know what pools you're looking at. Let's say you want to swap a token. But think about this not from your, I'm interacting with the debt once. What if you interact with this debt over, a few weeks, over a month, and now they see your profile? Oh, this guy, he likes to invest in meme coins. He likes to, to short. They see all this information, but if it's not actionable yet, it will be in the future. And either way, they can still sell your actual transactions to bots. So all of this is available.
Yeah. I guess what I was more so asking is what kind of personally intrusive data are they getting?
They're not getting, I wouldn't say they're getting personally intrusive other than what kind of financial. So in the Web2 world, it's more like your personal preferences and like what you're doing online. And in Web3 is more like your financial interests. like where's your money, what do you like to buy, what type of trade.
What about like my IP address?
Yeah, of course they can see your IP address. So let's go one step back. You're on your browser. You're going to Uniswap. Every time you go to Uniswap, you send a message to I think it's Alchemy right now, and they can see obviously your IP and a lot of information about where you're coming from. You're coming from Uniswap, what page you're coming from, information like that. What tokens you're looking at.
So if I have a social profile connected to a wallet and on that wallet, these RPC providers can see my connections and my IP address and my funds. So that, not great.
They can see your funds. They can see all that. Most of these things they can surely see. They can see because again, blockchains are useless without us. Why? Because it's the pipe that connects you to all the data. So when you're asking for the data, you're asked what data are you asking for? What's the context of that question? So once you have all that information, you can really build a lot of stuff around that.
And IP addresses are geographically oriented, and unless you're using a VPN. And so if I am trying to claim an airdrop or trade a meme coin, and for some reason I'm in a jurisdiction where it's not legal or allowed to claim an airdrop or trade a meme coin, who is doing that censorship? Is that the front end? Maybe let's say the front end says it's okay, they don't care. Would the RPC censor my ability to claim that airdrop or illegally trade a meme coin?
They could. It's possible. They could. I don't know if they do it. Mm-hmm. I know that in the past there were talks about RPCs blocking Tornado Cash, for example. So it is definitely something that they're capable of, but not to the full extent that you would think. There probably are ways around it in the end for the user. But yes, you can definitely censor and block users based on what they're doing on the blockchain. By just lying, you can lie to them. I could tell you your balance is a trillion ETH, or I could tell you it's 0. And you have no way of knowing if it's true. I'm just telling you it is what it is, and you take it as a fact. So I think it's really important that we solve for these issues: freshness, accuracy, censorship.
And this was part of the reason that Satoshi found it so important to run our own full node. Is that because then you couldn't really fudge the data that you were giving like to someone who was getting it from their own server on their own computer?
Yeah. If you run your own node, it's much harder to trick you. Why? Because you are verifying state. You're verifying that Excel file and it's on your computer. But if the file is on my computer, I can just tell you, oh, this is what's inside the file. Don't worry, you're good. But so we've been building this in a way that we've been building love in a way that solves these issues and allows you to trust the data that you see while not having the file locally. Because as we get more and more blockchains, we get more and more files, and no one wants to host them, and it's becoming so difficult. It's expensive, requires a lot of bandwidth, of storage, and requires DevOps. It's every time there's an upgrade, you have to update your executable. So maybe you can do it with one blockchain, but what if you have 10, 20? It doesn't scale. So each one of these providers that join our network is basically responsible for doing this. And they might be very good at Ethereum, but they're not doing Solana, or they might be very good at Solana, but they're not doing Ethereum. So this allows the network to bring in many participants who are each optimizing and is an expert in his domain. So I think that's a really good point to think about. So as we were talking about these modular layers, right, with consensus, the availability, everyone's talking about it. We're going to talk about it tomorrow: settlement, execution, right? What's missing? What's missing is the layer for modular blockchain data access. And this is what we've been building at Lava. Let's dive in a bit more. So when we were designing this from scratch 2 years ago, we were trying to think, what are the key qualities that an access layer that is universal for everyone, agnostic, needs to have. And it has to do this flawlessly. Because remember, this is the layer that connects everybody to all the amazing, already existing, beautiful technologies that everyone's been building. But this is the gateway. This is the door. So it has to be flawless. It has to work perfectly. So one of the critical parts is scalability. It has to really handle the surge of load. When there's an NFT, draw, I want to be able to not have an RPC error. When I'm claiming an airdrop, I want to be able to transact and not be frustrated with the system. Because if the system is frustrating, I'm just going to say, I'm going to go somewhere else. It has to be cost efficient, right? So in Lava, the service is actually scored and the rewards adjust based on score. So if you're a bad provider, you get less rewards, you get less users. If you're really good providers, you get more rewards and more users. It also has to be cost efficient for the chain. Remember, chains are usually, when they start, they pump a lot and there's a lot of traffic. So it should be more expensive to run them. But maybe a few months later, it's stabilized somewhere in the average. And in that scenario, they don't have to keep paying what they were paying, huge amounts of money to operate the public RPC for everybody. So they can lower their costs and make it more like a market where, the demand, there's like a balance. It also has to be low latency. So no one wants to wait. You want to see the price right now. You want to make a swap right now. You want to interact with whatever you're interacting right now. You want to get your account balance right now. You don't want to be waiting, 5 seconds to see it. It has to be agnostic and modular. Because there's so many chains, we have to make something that actually enables people and anyone to basically build and bring these new chains quickly to Lava. It has to be accurate, right? We talked about this. The data itself can lie to you. It has to be fresh. You have to make sure you're getting the latest Excel file. It's what's right now, your financials right now, not financials 2 days ago. And I think really, really important is decentralization. It's not just one person. It's not just one provider. It's many providers distributed across the globe so that, if one of them is down because of the surge or whatever, or they got censored, or their servers were disconnected from power, whatever, you can still talk to many others. There's always an alternative. Just like in traditional blockchains, when we're building a blockchain, we're making sure that, you can suffer up to, let's say, 33% faulty or malicious participants. It's the same for RPC. We have to make sure that if most participants are giving good service, the service is going to keep running. So how does it work from the rollup and the provider standpoint? It's very simple. A new rollup wants to launch. Let's say it's EVM compatible. It takes our what we call spec, which we'll show you later in the demo. It's basically this JSON file. It's like a schema, and it defines the different types of APIs. So if it's EVM compatible, then you just inherit from EVM, and you're good to go. You just change the chain name, change a few parameters that are unique to your chain. You deploy it on chain, and you deploy your token. Let's say you have a Rollup token. You deploy it in what we call a public RPC pool, and you say, every month, distribute 1,000 of this Rollup token to the providers. Now the providers are like, wow, I can get rewards from this, just like validators. So they come to Lava, they start running your software, your node, and start giving service to your users. They take Lava tokens, they stake them on your spec, on your Rollup, and that basically gives you the economic certainty that you're getting fresh and accurate data. Because if they lie, they can always get slashed, just like validators.
Is that the only, is slashing the only mechanism of enforcement?
No, you can do jailing as well. Jailing is where you get kicked off and your funds are locked, and you are now basically can't serve users, so you can't get paid. So this is the lower bit.
So
Who's doing?
boss? Who's the jail boss?
Lava is a decentralized network. So there's actually a protocol that's built. There's an algorithm that is built based on the service that people are giving and the ratings of that service that automatically jails or slashes. So how do dApps connect to Lava? So we're talking about providers, right? So now we have this huge list of providers. Why? Because 10,000 or 1,000 rollup token, that's pretty good incentive for everyone to join. Start anyone who's good with running nodes from, any regular person that knows how to, run stuff to actual like super bespoke providers on our network they have like data centers, or they have they're professionals in it. They can come run servers and give you the service. So now you can get this list of them. It's called a pairing list. So you ask Lava, can I get a pairing list for all these users, for dimension, let's say, in this example. You get this list, provided 1, 2, 3, 4, 5, 6, and you basically can talk to them directly. Remember we said it was decentralized? So in the traditional model, you just talk to one server. In our model, in the Lava network model, if you use our SDK, you are basically now directly peer-to-peer talking to any one of these providers. So there's no middleman, there's no way to, even if one fails, you can always fall back to the city.
How does Lava choose which RPC provider is going to service my request?
Okay, amazing question. So basically on-chain, providers stake Lava tokens on the Rollup chain. So, this is what allows them to give you service on the Metro model, for example. So there's a few ways that we are now building this list. And when I say we, it's basically the on-chain algorithm of the network. So think about how much tokens you staked and how many tokens, just like a validator, someone delegated to you. So if you have, let's say, 10,000 Lava staked and delegated, your chances are higher of getting selected for the list than someone who only has 1,000. So it's
like a lottery.
It's not like a lottery because it's weight staked.
Okay. But like if I have 50% of the stake, I have like 50% of the lottery tickets.
Yeah. So if you look at it like that, 100%. So it's a pseudo random, but it's weighted function. This is one aspect. The second aspect is also quality of service. So as users get and start using your service, they keep rating it continuously. Eventually it gets on chain. And all of these ratings are summed up. And providers who provide better service over time will get selected more frequently. The third one is a more practical way of filtering. It's like what you need. Let's say you need somebody only in Europe. So everybody's in the US. We don't, when you ask the algorithm, it's not going to give you somebody in the US. It's going to give you somebody in Europe. So these are the different types of pairing selection algorithms that we have. You get the list, and then you can talk to the providers.
Gotcha. So maybe a silly question, but what if I want access to Lava, but I don't care to have any stake or opportunity cost or price exposure to the Lava token? How do I overcome this bottleneck to get access to the network?
Yeah. So to get access to the network, you really don't need too much exposure. All you have to do is buy a subscription on chain with Lava. So you have to buy Lava one time. You can buy it for a whole year, for example, and then you don't really get exposure to the token.
Is this similar to Chainlink in the way that an application or a rollup might pay for Oracle services in the Link token?
It's similar, yes. I think that Link is more continuous, whereas in Lava you can buy. It's built like a SaaS where you can come on chain and just buy a package. You can buy it for 1 month, for 3 months, for 6 months, for a year. So it's really up to you.
Cool. So do I, as a user, as a chief degen, trying to fight for my life on chain and farm airdrops from Africa, do I need to pay Lava to use your high quality services, or is there some sort of like subsidies or like other opportunities for just your average user?
Yeah. So as we were saying, everybody today uses public RPC. Remember, all the users, almost everybody. So who's paying for that? Rollup token in this scenario. So Rollup token in this scenario pays the providers on your behalf. So you pay nothing. Okay, you just come and use the service for free. For free, they pay for it. But in this scenario, at least you know that there's no like ulterior motives for providing you this free service.
Cool. What is Lava over Lava? The LOL red circle. Yeah.
Okay, so remember I told you have to ask for the pairing list?
Mm-hmm.
How do you ask for the pairing list? Who do you ask the pairing list from? So you have to have...
And the pairing list is the the ordered pair of provider and app?
No, it's the list of providers for one app.
Oh, the list of all the providers for one app.
Yes, and this list changes every few blocks, every epoch. We call it every 15 minutes. This allows opportunities for smaller providers to also get into the list. So it's not fully dominated by the top stickers.
Got it. Okay. So the providers are running the RPCs from rollup to user, providing access to the Excel sheet. But you need access to Lava's Excel sheet in order to have access to all these providers that are going to give you access to the Excel, to the state and the balances. So you run Lava over Lava to get the providers for any given app.
Yeah, and we always did like clever names in Lava, so LOL. So this is our solution for this decentralized problem, right? Because if you're just asking our server, please give us the pairing list, then it's like, oh, so what's the point? You're just trusting one server. So instead of that, we have what we call Lava over Lava, which is anybody who stakes to provide Lava over Lava is a list of providers that you can load from anywhere, from your computer, from a website, from your snapshot of the blockchain. Take a list, very simple file, and you can just talk to these providers always, get the pairing list. And it uses the same protocol, so everything is trusted and accountable for.
I guess quick question going to the like the economics once more. Is it necessary to pay in the Lava token if I'm just a user or a rollup, or could I for instance, like taking a step back, if I have a USDC, could I commit that to the network and then in the back end the network uses that to buy Lava and purchase the program?
Yeah, so the rollup itself can pay whatever token they want for the providers. So they can put whatever, like rollup token, they can put Lava token, they can put whatever token that is bridgeable to a Cosmos chain with IBC. For the user, I'm assuming that someone's going to build like really cool interfaces to basically just swap and buy the subscription, USDC or whatever token.
Okay. And then eventually it has to end up in Lava to follow some slashing rules.
So just to clarify, when I say user, the only users that will actually pay are really high throughput apps that need anything above the public RPC. So the public RPC gets you wherever you want to go, but it's not something Uniswap would use, because Uniswap uses a bajillion requests, and it's not fair for the providers to serve a bajillion requests for whatever rollup token is being placed in the public. So someone like Uniswap, go on chain and buy the higher tier subscription, and this payment will go to the providers as well.
Okay. And then is it only the providers that could get slashed, right? It's not Uniswap or applications or rollups that would get slashed?
Correct. The slashing is, so a provider stakes in order to give you service as a user. Why does it stake? Because staking is a way to ensure that they have you have an economic certainty that they're not lying. Because if they're lying, there's a penalty.
Got it. Okay.
So So really cool features that I'm gonna glimpse over. Let me know if you want to dig in deeper. One is the provider optimizer. So as I was saying, you get this list of providers. Yes, they're rated by quality of service and they're also rated by stake. So you know how much you can trust them. But maybe you're in somewhere that is not really traditional. Maybe you're in a different continent, but where there's no good providers. So from this list, the provider optimizer, this is all done completely in the background. It basically probes the providers one by one, and checks who's the fastest. It also checks who has the latest data. So it guarantees to give you from this list the best provider for you, personally. The other feature that we have is constant availability. So we're talking about how the key qualities of what's important for building a universal access layer, right? So what if Lava blockchain holds? I mean, we've seen that happen in other chains, right? All of the RPC and all the other chains is going to stop working. That's unthinkable, right? This is something we cannot have. So when we built Lava, we built it with this feature. Basically, it allows providers to see that Lava stopped working, it's halted, and they can now in the background keep serving users and keep them accounted for. When the Lava comes back, they can send all of those relays on chain and basically get paid for the work is done while Lava was offline. So we make sure that even if Lava holds, you can still use it. And we've actually had holds on testnet, because testnet we sometimes deploy very interesting patches, check different scenarios, and we tested the feature to work, and it worked amazingly. One more thing is native restaking. So I was saying we have a Lava validator, which is just traditional Cosmos validator, which basically builds blocks, and then we have votes in the network. And then we have providers, which stake tokens, right? Yeah, and then they can give you service in RPC. So when you delegate tokens to a validator, you can also delegate the same tokens, basically restake them to a provider. When you delegate to a provider, you can restake that on a validator. We've done it so that first you have better capital efficiency, and also it balances the network, the voting in the network between the validators and providers. It's very important to keep them balanced so that they don't try to maneuver on one or another. It also improves it basically allows to restake the token, which is, I think, a really interesting way to promote better optimization of these the quality of service across the network. I think these are some super cool features. Let me show you what a spec is. So spec or specification, remember when the rollup is coming to deploy, he's coming to deploy his chain on Lava to provide this access layer to his blockchain. He builds this, what we call a specification spec. Inside the spec, he describes what are the APIs that are needed to perform this RPC, the service that the users are expecting to get. So they're a very simple file that almost anybody a little technical could build. And inside of it, there's two cool features I want to talk about. One is add-ons. So if it's a bit technical, let me know, or feel free to ask questions, guys. So add-ons are a way. So in Ethereum, for example, there's the usual APIs that I showed you, ETH_get balance, if you remember. But there's also debug_trace, for example. These APIs are way more computationally intensive to perform. So not all of the providers want to give them because they might be too expensive for them or they're not optimized for them. So add-ons allow you to put that aside and only let some of the providers choose to service that for an additional payment. Extensions are something like an archive node. So you remember that Excel file? So most nodes only keep this Excel file. They only keep, let's say, the latest 10,000 lines. But an archive node is an Excel file that is the entire history of the blockchain. So it's like a huge file. So it's very expensive to keep it. So what our extensions allow you to do, and this is very unique to RPC. This is something very new, and I think it's super cool. It lets you basically tell the consumer which provider to talk to. So if you have archive support, you get paid, let's say, 5 times more for this query, and the query will go to you. If you don't have it, then the user will send, if the user is asking for, one of the newer lines, will go to the regular provider. So it allows you like this smart routing of requests. So what are some options and which you can use? All these are available right now, by the way.
So Gil, real quick, I'm not sure if this specific functionality is what allows the extensibility of Lava or something else. But my silly question is, how does Lava scale to 1,000 chains and do it where other kind of heavier antiquated services cannot? Is it because of the SDK? Like why? How?
So SDK is one element that allows for that, because it allows for direct communication with providers. Whereas all the providers today, they rely on this central point where all traffic goes through to different nodes. Lava is more like this example, where you see this red circle or the metric rollup, for example. Instead of going through this one circle, you go directly to the orange provider. So let's say you have 10 of these or 100 of these. So you don't go through this central point. So it makes it more scalable and more, it doesn't have a single point of failure because there are many points to talk, many providers. The other way in which it scales to 1,000 chains is using this spec. Whereas, traditional providers, they have to go and they have to build infrastructure, DevOps, development to bring in a new chain. In Lava, you can do it in 10 minutes. You just build the spec, you deploy it, and then providers join. These providers might have access, there might be validators on the chain, and they start giving service.
And then the incentive program is just supposed to work such that as soon as the specs are deployed, there's enough incentives for providers to get active.
Yeah, if there's not enough incentive, they're not going to come. So as a chain, you have to make sure that there's enough incentives. If your chain is really heavy, let's say you're Solana, you need a lot, like a beastie machine to run it, then your incentive should be higher. If your chain is super lightweight, maybe you can put a lower incentive. So it's really like a market for these types of providers. And it should be instant. You just join, and at the end of the month, we tell you, the network tallies up how much each provider gave and the quality of service, and you get a reward. So one thing to think about Lava, it's like a distribution network for your nodes. So we have the server kit. It's the Golang implementation of Lava protocol. So basically, it allows you it talks to the providers for you. We have the Lava SDK, which is the same thing, only written in TypeScript. So you can run it from the browser, let's say from the Uniswap app, for example. And we have the gateway, which is more like a traditional familiar RPC provider, where you just get a URL. You're getting some of the benefits of decentralization, but not all of them. This is an SDK example. So we built this tab called All Blocks. And what it does, it uses the Lava SDK to directly communicate with all the providers on the network. So in this example, if you see on the right, you can see all of the probing and all of the relays that the SDK is doing to many, many different providers. And in the example, I think we're going to click on one of these relays, and you can see this one is served by somebody called Palamer.io to get the latest block. And if you click on a different relay, see if we do it here, then you will get a different provider. So you're talking basically to many, many providers at the same time.
It's one thing to think about all the chains that are going to be live and deployed in the multi-chain future. And then your demo just reminded me, all those chains are also going to have test nets. And so it just expands this RPC scalability issue even further.
And definite.
and test nets and multiple reps. Yeah.
Yeah, I mean, it's been super exciting to build this project. You know, it's like the underbelly of Web3. It's like the Achilles heel of Web3, right? No one talks about it. No one talks about how it's super centralized and how chains are now bootstrapping RPC. But everybody feels it when you go to claim an airdrop, when you're trying out a new testnet, when a new chain launches, when NFT drops. Everybody feels it. So, you know, we've been building this, and we're super excited. And I've been super excited to share this with you guys.
There's the old adage of don't trust, verify. And I think right now in the current landscape, this is very much a step in the right direction, because Alchemy and Infura, without naming, you know, the rest of the centralized providers, like, they are very centralized. It's very much a trust that your data is accurate and secure. There's no verification. And then this, you know, there's obviously more decentralization. And so we're trusting a decentralized network instead of a centralized network. Is there an element of verification? Basically, how do you continue going in the direction of more verification, less trust for this network?
I think that's a really great question. And there's multiple ways to approach this problem. And when we were thinking about this 2 years, we went with what we call the optimistic approach. So just like for Rollups, when you talk to work, like use an RPC to send a transaction to a rollup, and then it tells you, oh, confirmed. You made the trade, you made the swap, you transferred the funds. Then your friend looks at the transaction and is like, okay, I can give you the pizza, whatever. So now there's an element of trust. Why? Because again, most rollups today are optimistic in nature. That means that they post the updates on the DA or let's say on ETH, for example, and then there's a dispute period of 7 days, and so like OP Stack still hasn't, for example, fully implemented fraud disputes. So how do you know like that it's actually not going to be reverted or that it actually happened correctly? So it's very difficult to do. But this dispute mechanism allows you to slash a bad sequencer, right? That's the core idea. So as you go up in speed, you can't verify. You just can't. If you start verifying, it's too slow. It's way too slow. So what we've built is a similar approach to optimistic rollups. So for example, you get a response. It tells you your balance is 200. Every once in a while, you roll the dice and you ask another provider the same question. What's my balance? And then you compare the two results. Because blockchains, the Excel file is deterministic, and everybody agrees on the same state for the same block. If there's any mismatch in the hashes of the response, you take this, what we call conflict, and you upload it on-chain. On-chain, we have a voting mechanism. So all the providers that are chosen by the jury re-execute the query. And if the majority says that you lied, that one of the providers, the majority wins, and the minority might get slashed, and the majority might get a reward. Same for days.
Yeah, and this deterministic property of state is also the reason that like data availability sampling works in Celestia, because as you sample, the likelihood that you find any kind of conflict decreases exponentially as you get one commitment, two commitments that all agree to one another. It is increasingly unlikely that you find any kind of conflict.
Exactly. Yeah. So the more you check, so it's like a mechanism to deter bad behavior. So this roll of the dice, if it catches you, you could lose everything you've worked for. So that it doesn't, economically doesn't make sense for you to give bad results.
Awesome. Well, Gil, it was an absolute pleasure having you on. I feel like I learned quite a bit about this piece of the modular stack that is not talked about very much, and I really do appreciate you shedding some light on it.
Thank you. It's been a pleasure to be here, and let's hope we talk about it a bit more and let people know that they still need access to their data. They need to access this.
Definitely.
That's what we're building.
Definitely, and I know that it's the You guys have a staggered set of launches up here, so I hope that those go all smooth. I know that the community is pretty excited about the points program and things. Do you have anything on that?
Yeah, feel free to come join us, join our community. We have a huge community. Bring your chain, be a champion, or push the different specs on chain. Help us bring the word.
Awesome, man. Thank you for coming on.
Thank you guys so much.